Hi everyone, my name's Glenn and I work at a little company called Geckoboard. But today I'm going to be talking about some work that me and my team did at CircleCI. So let me set the scene first. So CircleCI is mostly made up of microservices and they're written in Clojure. And they all share some common tooling using a shared library. That library is maintained by a separate team that tries to help act as an accelerator for all the other teams and keeps that library up to date. Meanwhile, each CI build that runs on our platform defines its own CI environments. We run the infrastructure, but they get to decide what dependencies and so on are installed on the system. And in order to power those builds, we needed to implement a build agent, a bit of code that can run anywhere on those customer-defined machines. And we implemented that in Go. Now my team was responsible for this agent written in Go, that build infrastructure that it runs on, and some of the microservices that it communicates with. And we decided we needed to build a new service for an upcoming build agent related feature. And we decided that rather than Clojure, we were going to make a bit of a departure, and we were going to also build that in Go. And there were various trade-offs involved in this decision, but overall we were confident that this was a good choice. And now I'm going to claim that this resulted in a fairly unusual situation, or certainly unusual to me. So we had quite a large team of mostly experienced senior engineers, and we had experience working together building software in Go to build this build agent. And we also had experience of building web services together in Clojure. But because of the choice to build this new service in Go, we decided we'd left ourselves unable to use that shared library, and so all of the tooling and the patterns we had were for writing a CLI tool. We didn't have any of the scaffolding, that standard library stuff for building a web service. And I think this was a relatively unusual situation. And in particular, this situation was a real recipe for bike shedding, for bickering and debating over people's personal preferences for things that aren't really that important. But as well as the bike shedding, I think it's also a great opportunity for some experimentation, for some chances to try some things that we haven't really tried before. Try and mix things up a bit. A little bit more relevant background knowledge, and I think this is sort of quite relevant. The story is what CircleCI's observability was like at the time. So this story takes place sometime around summer 2019, and possibly back then. This was before the term observability had really started to get really heavy use. But CircleCI had a two-pronged approach, and both prongs were really expensive. So StatsD was the primary tool we used. We used metrics. We had lots of metrics and we had lots of tags. And if you're familiar with StatsD, the pricing model for StatsD, and actually the underlying cost of the system itself, is based around the unique combinations of tags that you use. So the more tags you use, the more it's going to cost you. We also had a rather expensive self-hosted Elasticsearch system, and that's where all our structured logs went. And that's generally the thing we're comfortable doing, adding logs to our system with occasionally some fields that we can query. And around this time, we'd started working with a new kid on the block, and that was Honeycomb. We'd had a period of database problems in the spring of 2019, and to help us uncover what was really going on there and get a bit more visibility into our system, we'd started exploring Honeycomb, and it really opened our eyes to how our systems were behaving in production. We'd started to spot things that we hadn't really appreciated before. So I was hooked, and I'd started looking at Honeycomb before even checking metrics or logs, even when we had only instrumented quite a small proportion of our overall stack at this point. We were also starting to see tweets like this floating around. So this is Charity, one of the founders of Honeycomb, and she's railing against this concept of 3 pillars of observability: metrics, logs, and traces. She's claiming they aren't really a thing. And I was starting to buy into this. So I proposed an experiment. Given this situation, we've got a little bit of a blank slate, but we know what we're doing, we understand each other, we know how to work in the programming language, we're not completely inventing everything from scratch. yeah, I proposed this experiment. And if you've read the title or the abstract of this talk, I'm sure you know where I'm going next. I said, what if we didn't have any logs? And, what does it mean to not have logs? Well, we kind of need a definition of logs in order to not have them, I think. So this is the definition I'm going with. So logs are text-first telemetry. So telemetry meaning the information our system emits in order to understand what's going on. And text-first meaning when you're writing a log line into your code, you're thinking about it in terms of the text it produces. Logs are intended to be human readable. You're usually writing a log as a message to your future self or some other operator. Little message in a bottle, as it were. If you're lucky, the logs will have some structured data attached, some key value pairs to provide a bit more context about what's going on that are queryable. If you're less lucky, then that extra contextual information will be part of the human readable bit of the log, which will make it much harder to query against. And logs are generally scattered across the code base. There isn't like a common pattern for exactly where a log should or shouldn't go. You probably are trying to debug an issue and you realize there's something you'd like to see that you can't see. So you go back into the code, you add that log line and then you ship it. And then now you've got a new log line and you've got that additional visibility. Logs are pretty much always visualized and explored as a stream, sometimes as just text with grep, sometimes in like visual log aggregation tools. But even then, they're still usually thought of as a stream of text going past that you have some way of picking the relevant, the lines that are most interesting to you within them. And logs also have this concept of a log level. So debug, info, warn, error. Some logs are more important than others. And when we configure a system in production, we often disable debug logging. And I'm sure many of you have been in a situation where you've had a production issue, you'd love to see what's going on, and you've looked in the code, and there is a log line that would tell you exactly what you need to know, but it's disabled in production because it's just way too noisy. So that's logs. And if we don't have logs, what do we have instead? Well, we'd have what I'd like to call an event-first approach. Not the catchiest name, but I think it's a reasonable term. And again, we need a definition. What is an event-first approach? So I'd say an event-first approach is, as opposed to text-first telemetry, it's data-first telemetry. We're primarily thinking about describing what's going on in our system as data. We do that via events, and each event has a unique name that identifies it within our code base and describes the action that's going on. All of the properties of that event are structured data. So this is partially by virtue of it being new. Like generally now, if I'm writing a new log line, it will also all be structured data. But when I'm creating an event now, the event name is just an identifier, and all of the data about that event goes into properties as structured data. We're also going to wrap these events around units of work and mark the duration of that unit of work. And when I say a unit of work, I mean something important that our system is doing. So rather than like having a log line for like, yes, a thing started, yeah, it's still going, okay, it's finished now. With an event, I'm going to wrap that unit of work and I'm just going to emit an event when a piece of work is completed. And then it'll have all the properties I require and it'll know the duration of that chunk of work. Events, we're going to explore and visualize in multiple ways. So that includes the stream that we get for logs, but it will also allow us to do time series queries and other types of ways of slicing and dicing that same bit of raw information. And we're not going to have log levels or any equivalent. So where in the logs-based system we say certain events are more important than others, in an event system we're going to say all events are important in terms of the code level, and if we're struggling with volume and we need to like throw some away, we're going to use dynamic sampling techniques, which I'm not really going to go into today, but if you want to Google it, that's the term to Google. Now I haven't put these both up on the same screen at once, but you might have noticed these are quite similar lists of bullet points. And I would say that events and logs aren't actually that different. Events are just good logs. But something I've been saying to myself at least, for a number of years, is I'm going to stop using the word just. There's a lot of hidden meaning behind the word just. It implies a certain level of triviality, which I think is rarely the case. And even if events are just good logs, I think there's an important philosophical difference there. And in particular, I think new words can encourage new ways of thinking. Many of us take our logs for granted. We don't put a lot of thought into what we're writing in our log lines, or we've been using logs for years, so we know how to do logs. But suddenly I say, hey, we're doing events now, and you go, oh, that's different. How do I do that? And so I think, it's using new words, new terminologies, new APIs is an important tool in our toolbox, because ultimately we're building these systems for people. And so finding ways to change the way people think is an effective way to bring about change. Anyway, so that's enough philosophical nonsense. Let's see what this looked like in practice. So I'm going to show a bit of code now. Hopefully you're familiar enough to follow some Go, but even if not, I hope you can still appreciate how minimal these interfaces really are. So we've defined our package with the trendy O11Y name, and we've got a start span function. So this is going to create a span, with the span representing a unit of work, and it's going to store it in the context. Context, if you're not familiar, is a Go's equivalent of, say, thread local storage, but it's explicit rather than implicit. Anyway, so we're going to create our span, we're going to give it a name, and then once we've got a span, there's only two core operations we really need on a span. The first one is to add a field. This has a key and a value, where the key is like the name of the data, and the value is anything we like. And then after a span has run for some time, we'll call this end function on the span, and that will record a duration from the start to the end and send it off to the back end. Fairly straightforward, I hope. And then when we write our application code, we're going to sprinkle a little bit of this span code in throughout it to produce the telemetry. So in this case here, we are going to start our span and we're going to name it delete entity to match up with the name of the unit of work that we're performing. We're going to use Go's defer construct so that when this function ends, it captures the error and the span ends when the function ends. And then throughout the body of this function, we're going to use a series of these add field calls to add important context about what's going on. Generally sort of domain specific information about what's happening within this function, what work we're performing right now. And then when we do this throughout our code, we can send it off to Honeycomb and we get to see these nice little trace waterfalls like this. If any of you have used some sort of tracing tool, I don't think this will be a revolutionary concept to you. You'll have seen a lot of stuff like this. And as we browse around the Honeycomb UI and we click on these rows, all of that extra field data that we attach to our spans will be viewable in the little sidebar. So we started from first principles, we had this really super minimal interface, and then as we worked on it over time and built up this new system, we started to develop and extract some patterns. And one of the first patterns that emerged was having a consistent way to capture errors when a span ends. So there's a little bit of sleight of hand here with like named return values and pointers and so on. But the general idea here is that whenever this function ends with an early return or whatever situation, the defer block will run, and we're going to call this standard helper, this end function, to end our span. And this makes sure that every time this function ends, it goes through our helper. Now, there's another way to do the same concept, which will be to use a slightly more aspect-oriented style where we wrap our code with an observability layer that respects the same interface as the actual code. And we found of the two approaches, we much preferred this inline approach where we actually clutter our code with the observability code. And the reason for that is generally when you're coming to make a change to the code, because it's right there in your face and in your way, then you're much more likely to remember to update the observability code to match. Whereas if it's off in a separate layer, it's very easy for the two to fall out of sync. Now, inside the body of this helper function, we've just got some really basic logic to ensure that we've got consistent storage of fields. So every time there's an error, we're going to set the result field of the span to have a value error, so we can very easily find spans containing errors. And we'll also populate the error field with some details about what went wrong. In the real version of this, there's a few more cases that handled for like timeouts and so on, but this is the core concept. And when we send this off to Honeycomb, it's able to highlight all of those errored spans and pull them out so we can see them clearly. And if you've got a much longer span, or much longer trace, and only one or two of those have errored, this is way more visually helpful. But it also means we can do a time series query on those same fields. So here I've taken a single one of those names and I've said all the spans with a certain name, show me whether or not they errored. And you can see there's some spikes here where, clearly something went wrong and those errors, those error rates spiked up, and maybe that's something worth looking into. Another pattern that emerged is what I like to call medium cardinality span names. So cardinality is the number of unique values of a particular field. So for example, earlier that result field, that's only got 2 or 3 possible values. That's low cardinality. Whereas something like a customer ID is high cardinality. Hopefully you've got a lot of customers and there's lots of possible values of a field like customer ID. So low cardinality values are really great for grouping events together. You can say, okay, show me how many events failed versus passed. Really useful. Whereas if you say, show me group by customer ID, you just get loads of separate rows. Not quite as useful for grouping, but when you're looking at a single event, knowing exactly which customer it affected is really effective. So medium cardinality, as I'm sure you can guess, is somewhere in between. And I've often found that auto-instrumentation will default to quite low cardinality span names. So for instance, something like it might just say HTTP request, or select query, or insert query. And when you're looking at a trace waterfall and it says something like HTTP request, select query, insert query, it's not entirely clear what's going on. Whereas what I found was by using medium cardinality names, so in this case the pattern we did was generally package method, and occasionally we'd also prefix with the type. So the examples I've got here are like a gRPC call or a database query. Just that extra little bit of context means that when you're looking at a trace waterfall or when you're grouping by span name, you can immediately see what action is going on rather than having to drill down into the individual spans and look at their fields. So it's generally just gives you a much quicker at a glance view of a trace. Another thing we started to notice fairly early on was cost. So as I mentioned earlier, we already had 2 very expensive telemetry backends. We didn't really want a third expensive telemetry backend. And I'm sure you can imagine Circle CI is quite a high volume system, millions of builds a day, lots of RPC calls as part of those builds. Anything that multiplies per call gets very expensive very quickly. And if you take a naive approach, a naive application of the approach I described above, where each layer gets wrapped with some spans to denote the unit of work, you can very easily end up with a trace like this one. So I've got 4 different spans, each representing a different layer of our code, but ultimately there's no other code happening in that request handler. So all of these spans are mostly recording redundant information. And so when we started to see traces like this, we got a little bit more selective about which layers really benefited from being considered units of work versus just being delegated down to the other layer. Like in this case, the top layer there is the HTTP handler, and the second layer down is like the domain layer, which is the core of our application logic that's separate from HTTP. And so we made some tweaks to how many of these spans were produced. And that did save us actually quite a bit. But when we're throwing away spans like that or reducing spans, we are losing a bit of information, and we then developed a few patterns to try and get that information back. So generally adding lots of domain specific fields onto spans. In Honeycomb, it doesn't cost anything additional to add more fields to make a span wider, so it generally tends to encourage you to do that. So for example, in the previous trace there was like an HTTP client that did retries, and that was creating quite a deep trace, whereas you can, instead of having a span for each retry attempt, you can just have a counter on the final one to say how many attempts were made, and that way you're losing a bit of information, but you're still overall capturing what's going on. And we've also found that, well, in a microservice system, you've got loads of different storage backends, lots of different identifiers. It's very helpful to add as many of those onto your spans as you can get away with, And then when you do have an issue, you can see exactly which customers it's affecting, or even in many cases, which customer is causing that issue. Now, anyone who spent some time instrumenting their code with modern tracing tools is probably mostly shrugging at this point. You'll have come across many of these patterns in your own work. At this point, I'm just instrumenting with tracers. And there's that word just again. And so far, yes, I haven't really done anything new apart from not introducing logs. I'm instrumenting with just tracers. But actually, when I said no logs in the title, I was lying a little bit, or bending the truth perhaps. When I first proposed this experiment, some of my colleagues were a little bit wary, and they had quite reasonable questions, like, what will we do if Honeycomb is down? How will we see what's going on? We had this logging system that there were things we didn't like about it, but we understood its operational constraints. We knew how to operate it. And switching entirely to a brand new approach, can be a little bit scary. So what we ended up implementing was a little T inside the Ollie library. So as well as sending events to Honeycomb, we also converted them to JSON and wrote them to standard out. And that way, we were able to, after sending them standard out, they then pumped off to our standard log aggregation system. And this way we've kind of got a fallback. If Honeycomb's not working, we can just see our logs normally. And you could imagine we could also send these off to S3 or some other long-term storage system if we wanted. So yeah, we've got some JSON logs out of our tracers. And these aren't super usable. They're not particularly readable. It's just a big wall of text. But actually, we found ourselves using them. And in particular, we found ourselves using them in local development. Because we all have this habit, this pattern of when you're working locally, you expect to see output from your process right there in your face. When you do things, you want to be able to see that immediate feedback loop. And so, because we started using these JSON logs, even though they were difficult to read, we made them easier to read. So with a little bit of parsing and a little bit of color, we can immediately add a lot more information architecture. We can pull out the span name in color here. If there are any errors in the span, we can tag those and make them really pop out. And we can abbreviate things. We don't need the 36 character trace ID in our standard out dev output. We can, just take a few characters, enough to make it visually distinct and see what's going on. And actually, we found this was really most effective in tests. The Go's test runner can capture standard out, and it will display it next to a failing test. So you get a test failure, you can see all of the traces, all of the spans that happened during that test, in color, in text, right there next to the test failure. And this was almost accidental, really, but this turned out to be one of the most effective changes. Because now if you've got a failing test and you can't tell why it's failed, then that means your code is not observable enough. And the solution to fixing that is not to go fire up your debugger and figure out what's going on in this particular case, because this same sort of issue might also happen in production. The solution instead is to extend your tracing code to add new fields, to add new spans, so you can see what's going on. And then, the reason for the failure of your test is revealed, but also you've enriched your observability, you've enriched your telemetry, so that when this code makes it to production, you can see what's going on. So that turned out to be really quite surprisingly effective. So we've got some logs back. What about metrics? What about that third pillar? Now, it's become a bit fashionable lately to really hate on metrics dashboards. But I've used metrics dashboards for a lot of my career now, and I know how to read them, I'm familiar with them, and I think I'm still a big fan. And what I especially like is a dashboard like this. So for each and every service that we run, I like to have its headline dashboard. Is that service looking all right? How's it doing? What's it up to? And when we develop new features for that service, we also add them to the dashboard. We co-evolve them over time. It's not just a static artifact. And when I'm then deploying that service, I've got something that I build into my process as something to look at. I'll always open up the dashboard, I'll hit the deploy button or merge my pull request or whatever the process is and check that things look okay. I still think I'm slightly better at spotting patterns during a deployment than an automated regression system. Especially because that system is averaging everything over time, whereas I know what change I've just made. I know what might be likely to be affected. And currently today, Honeycomb doesn't really have a way to do something equivalent to this. It doesn't have this let me just have an overview. And at Circle CI, we're very familiar with the system we had. We didn't necessarily want to throw that all away just because we liked this newer way of instrumenting our code. So I asked myself, could we derive our metrics from our spans? We've said there aren't 3 pillars. Metrics are just another way of looking at events. And I really liked how simple and minimal the telemetry code we'd already added was. I didn't want to clutter it up with an extra layer of metrics code over the top. So I had a little play about, and I found an approach that I quite liked. So we take our simple span interface and we add one additional method, the record metric. And that takes a description of a metric to record. And then we have a series of factories that can create those metrics descriptions. So here we've got like a timing function that creates a timing metric, an increment function creates an increment metric, and so on, so on, so on. And then when we want to use that, we take our existing span and we add this, we tell it to record a metric. And then under the hood, the code will then derive the metric from the span's data. So when we say a timing metric, we know the span, the library knows to take the timing metric using the duration of the span. And then these extra fields on the end here tell us which tags we want to attach to our metrics. Now we have to be selective about which fields get recorded as metrics tags, and that's down to cost again. It's really expensive to send a high cardinality field to the metrics backend, so while we want those fields in our spans, we have to pick a few of those as being safe for sending off to our metric. So in this case, for an HTTP request, all we can really afford to keep is the status code and the result. And I think maybe we'd take the path or something as well. But anyway, we make the author explicitly choose which fields they want to associate with their metrics. But other than that, all of the values for these, the value of result, the value of status, and the value of duration, all come from the properties of the span. Much like the logs, our observability abstraction is then able to tee these off to a statsd daemon, and from there it goes along to the metrics visualization tool of your choice. And by ensuring that the metrics and events both have the same source in the code, there shouldn't be any discrepancies in the values between them. So, ta-da! We've got all of those 3 observability pillars. And only by adding really one set of instrumentation into our code, or one and a bit perhaps, you might argue. And I'm sure you've seen, if you've been researching observability over the last couple of years, you'll have seen many variations of this slide, the 3 pillars of observability. And in fact, I've realized we've been looking at this pillars diagram all wrong. If you look at it from above, the pillars are hollow, and they're all just windows into the event happening under the hood. And if you think about this in terms of the execution model of what our code is even doing, it kind of makes sense to me, because ultimately our code is executing a series of instructions with some arguments, and the act of instrumenting code is deciding which of those instructions and arguments we think are worth recording. Those are events, and anything else we derive from that point is all from that same source. So, at the start of this, I described this sort of situation as an experiment, and was it a success? I think so. It wasn't a definite success. I think it's definitely, yeah, there's some pluses and minuses. So on the whole, yes, I think this was a success. And I definitely learned a lot about what was really important to me when adding telemetry into my code. One thing that I think was a definite success was having only one source of telemetry in the code. Not having, a log line here and a span here and a metric here, just being like, okay, this is the telemetry code, and separately I'll worry about how that gets off to the back end. So yeah, that bit I can say I'm definitely happy with. The trace first mindset I also thought worked really well. So sort of training us all to think in a sense of, here is a unit of work that I'm instrumenting. Here's a unit of work that I'm wrapping with a span. I think that worked very well, rather than having a log line at the start of something and a log line halfway down and another log and then a log at the end. Just, it's wrapped, it's a unit of work. That part I think works great. The bit that I think didn't necessarily work as well, or was arguably not as worth it, was the whole let's burn everything to the ground and start again from scratch. The rethinking everything from first principles, bit of a mixed bag. So in the process of rediscovering everything, we spent a bunch of time bike shedding, arguing over details that turned out to not be important in the end, reinventing a bunch of wheels. Perhaps that process was still valuable, because in the process of having those discussions, we built a much better understanding as a team of what was important to us, and we also discovered like what we needed to include and what we didn't need to include in this library we built up. The other thing that was a bit of a mixed bag was not having any auto instrumentation available. So because we've just invented this new approach, it's not like we can just grab something off the shelf that will automatically create all our spans for us when we make requests or database calls. And the reason I call this one a mixed bag and not just a straightforward negative is because I've had very mixed results with auto instrumentation itself. I often find that the things that the person who wrote the library considers important might not align with the things that I consider important. And auto instrumentation can be very chatty. I could be creating a lot of spans for details that I don't actually care about. The cost benefit might be off there. So effectively, by not having this available to us, we were forced to instrument everything ourselves. But in 2022, all the instrumentation code out there is open source. If you want to instrument code in a new way, you can fork it, you can refer to the way it's done elsewhere. So it wasn't a huge undertaking, but it did give us the opportunity to reevaluate, did we want this field? Did we care about this bit? How do we want things to work? So yeah, bit of a mixed bag there. Anyway, so what next? What should you do with this story? Well, thank you for listening to me. And here's what I like. My recommendations for what to take away from this would be, first off, try a trace first approach in your own code. So regardless of the interfaces or how the code or how you're actually plugging things into your code, when you're writing new code, try and think about units of work and traces as the primary way of getting telemetry out of your code. Start from that first and then think about logs and metrics afterwards, maybe if you need them. I think that was very effective for us, and I think just that way of thinking even just helped to structure our code a little bit nicer. But I tentatively recommend this concept of a unified telemetry abstraction, having this one place to produce logs, metrics, and events. And the reason I'm tentative on this is because people still found it a little bit weird. It wasn't like as intuitive, and maybe this isn't an area you really need to innovate in. But I think it was effective. So I would still say it's a good approach, but maybe it's not worth, it's not enough better than the current approach maybe to consider ripping things up. But worth a try. And if anyone else is, like some of you right there might be hearing the words unified telemetry abstraction, and you may think about OpenTelemetry. So OpenTelemetry is an open source project. It's community led. It's got a load of vendors signed up to it, and its goal is to be a unified telemetry platform, to be able to. So when you grab things off the shelf, they come with instrumentation out of the box. They've got all that detail in there. Means that when you're writing instrumentation in any language, you've got a standard way of doing it, and it's a really great project. But one thing that's really different to OpenTelemetry compared to what I've described today is that they still have this very strong distinction between traces, metrics, and logs as different APIs. And I don't know if they're interested in trying to consolidate these. I haven't asked them yet. Maybe I will. But yeah, so OpenTelemetry, you take traces, metrics, and logs separately, and you plug them into the OpenTelemetry box, and then based on your application configuration, it sends them off to sort of one or more backends as required. So I think if I was doing this experiment with OpenTelemetry, I think I'd still want that extra layer over the top, so that in my application code at least, things just kept, I only had that one bit of telemetry code that then teed off to the various different types. Anyway, so that's my conclusion. Thank you for listening to me today. Thanks for coming along. And I'll be opening the floor to some questions.
Hello.
Hi there.
So much, Glenn, for that presentation. That was really interesting to see your experiences with a different way of doing telemetry in your application. We have a few questions that have already come in, and I hope that people continue to ask them in the chat. We'll get Glenn to answer all of your questions as they come. And the first couple were about maybe the specifics of experience with logs and how does that translate to this world with kind of event first. And so a really good example I often hear come up is, what do you do with the exception handling? So what did you all do with that? Were those also sent to Honeycomb?
Yeah, so I'll answer this question in a few different parts because so partially this story takes place in Go, and anyone who's worked with Go will know it doesn't have exceptions. And actually, out of the box, like the traditional pattern with Go errors is to just kind of pass them up, and they don't get any context. There's no stack with them, so they're actually just really annoying as errors. You just get an error that says like file not found. Like, which file? Where from? I don't know. But then, like a few years ago, Go added this error wrapping feature, and then so each layer of your stack, you like put a bit more context in the error as it travels up, and you end up building your own stack traces, which it's not the greatest system in the world, but it kind of works. And yeah, so we do include the full, like all the layers of the error, that all as much information as we've got about any error in the Honeycomb events. So the convention, like the field we had there, like the error field, that would be the string of an error, which effectively included all that stack information. And it did mean that in a single trace, if you get an error like midway down, you would get this span would error, and the parent would error with a bit more information. The parent of that would error with a bit more information, and so on. But generally, if that error wasn't handled in a way that like sort of turned into a non-error, when it got all the way back up to the top, then that error would be the low error with all the extra detail and the full stack. But I have also done this approach in languages which do have stack traces, and generally, yeah, I would have, so in those cases, I would have the error field be like the string version of the error, which is a bit shorter and it's kind of, you can consume it. But I would generally also add the full stack trace in another field. We often, like at my current job, we use Rollbar, no, not Rollbar, but yeah, tools like Rollbar, Airbrake, and Sentry, and so on, like exception tracking tools. So you can often pass the full stack of an error over to that, and that handles grouping and those sorts of things. And then basically make sure you include the trace ID when you send it to those tools, and then you can link everything up and match things together.
Yeah. Yeah. And I think the practicality of it is, of course, stack traces can get quite large. And so no matter what tool you're getting to use, there probably will be a limit of how many characters, how large those fields can get, but they can often handle quite a lot. And so that is, I guess, there is some practicality there. But otherwise, yeah, throw it all in, get it all included.
Well, exactly that. And when you're exploring the data, there's kind of, as I showed in those examples, there's multiple different modes of exploring the data. So like if you're plotting a time series and you want to group by, you probably don't want to group by a stack trace because there's enough difference. But then once you've clicked into a trace and you found a single error, you probably do want to see that stack trace. So having those both things available in different fields, I found has worked quite well.
Different fields, but same UI, same kind of tooling.
Yeah, exactly. So you don't have to go off and like open up another tool and log in again and, you know, go through your two-factor auth code just to see like a bit more detail of your error.
Of course. Great. There was kind of a paired question with this, as you spoke a little bit about telemetry at scale, and so how you'll use like logging levels with logs, and you might use sampling with this event first. And so there's a question here around whether or not you send all service invocations to these kind of event telemetry, or if you don't trace all of them. How did you all handle that?
So in the story here, we were building a service from scratch. And so every time we added a new service or a new dependency to it, we would add the tracing straight away. In other scenarios, we've had an existing service that has a lot of dependencies already. And generally, we'd sort of be driven a bit more by needs. So we'd go back and add telemetry when we're discovering a problem with that service. And actually, what I found when you do that sort of piecemeal adoption is that when you then look at a trace, you go, oh, there's a gap there. Why there's a gap? And then that kind of just gives you that nudge to go and add that extra tracing. So you kind of, once you get used to seeing these traces, not everything linking together, as soon as you get like a trace that's got a bit missing, or a trace that like, well, hang on, no, somebody should have called me. Where's my parents? Like you start to go around and add all these correlation headers and so on. So everything all links together nicely. Obviously, the downside of that is that, well, not obviously at all. So the way tracing decisions work in most modern sort of tracing tools is you either keep a whole trace or not, or none of it. So the more stuff you link together, the more expensive it is to say, yes, I'm keeping one. So when you start to do dynamic tracing, then the cost of keeping each individual trace increases. And that cost hopefully is, you know, proportional to the value of the trace. So something I've been really wanting to experiment with for a while is what I like to think of as like horizontal sampling. So can I keep like a slimmed down version of some traces? So like maybe I'll just keep the top level span from each service, but not the detailed spans on like 9 out of 10, and then 1 out of 10, I'll keep the rest, or always on errors. So that's not something I've had the sort of either enough of a need or the opportunity to explore yet, but there's definitely some stuff you can do that's similar to log levels without quite being the same as log levels.
That's exactly what I was thinking of when you were describing. It's almost like you can add a level to your subspans that then you decide,
Yeah,
which
but
ones
then
get kept.
trying to have that sort of dynamic tail sampling thing where you say, okay, well, if it's an error, capture more. Like I've worked on systems in the past where there was a special header that was undocumented, that if you set an HTTP header in your browser, then it would turn on debug logging for that request. And those tools are really helpful for like, okay, if I can reproduce an issue, then I can, run it in production with more logging.
It's very interesting. Yeah. Some more questions around the kind of usability of this. So and developer experience. And there's a question here around the annoyance or level of friction and readability when you had to add those span and error calls across your stack. How did that work for you?
Well, so again, in our case, this was in Go, and it's all of the libraries and code we were using were quite sort of modern Go, so they all had this context parameter. And Go is pretty, basically the convention is to pass this around, and that's where you stuff all your data in. So that's worked really well. I've had a different experience doing this in JavaScript and TypeScript, where the way the event loop works and the asynchronicity, sometimes the task can get lost. But there are helper functions certainly in the Honeycomb instrumentation libraries, and I believe in the Open Telemetry libraries as well, that basically let you give it hints when you lose that sort of information. So yeah, most of the time it kind of just works, and the spans and errors, everything sort of links together. Sometimes even in process, you have to give it a bit of a hint. And then to cross process boundaries. So if you're doing like common RPC things like HTTP or gRPC, then usually out of the box, you get effectively headers which match up the IDs and pass them across process boundaries. If you're doing things like if you're putting messages on, say, RabbitMQ or Kafka or SQS or queue-based systems, then generally, at the moment at least, I've seen you have to roll your own. So you take the same headers that you would put in an HTTP request, and then you add them to the metadata of your queue system, and then you unpack them at the end if you want to link them up. And there's various trade-offs about whether that should be the same trace or different traces. So I think there is a bit to think about there, but it's not, each individual choice is actually quite cheap to make. They're not really complicated things. It's just like, okay, well, do I want to link this together? And if so, I'll do it. It's just, ultimately, it's just passing a couple of strings around. It's not that difficult.
Absolutely. Thank you. I think that also kind of touched on that next question around correlating logs and traces and metadata and how you're able to pass that through with things. Is there any other way in which you connect your event data with anything else, viewing it in, as you said, the Elasticsearch that you had and things like that, other than just kind of trace IDs and things?
Yeah, not really. I think so. Some of the systems I've seen where we've added trace information to already had like a request ID concept within them. So we add that to all of the various different backends. Generally, when I'm working on newer systems, like they've never had that before. So the trace ID and the span IDs, those are treated as the ones that like the things to tie everything together. So when we send our errors off to Rollbar, then we add a section for like, here's the trace ID, and so they can match those things back up again and so on. Awesome. And likewise, even in the logs, we make sure it's got the trace ID, it's got the span ID. So if, say, you're on a system where you're keeping all of your logs, maybe sending them to S3, but you're dynamically sampling your traces, you can still say, okay, well, here's the dynamically sampled ID, can I like match that up to the other ID and so on.
That's great. Yeah, I think you went into great detail about how you are using this kind of third-party SaaS product, but also having a bit of realistic awareness that things go down, and what do you need to do in those cases, and sending that to a second location. So there is a question here. Have you pragmatically had to deal with that? Did you ever try and send traces out when Honeycomb was down or was experiencing issues? And what happened with that? Did you lose those traces from that view, or was it just delayed? How'd that work?
So for Honeycomb, I think they have had a handful of like outages, but nothing major so far, like touch woods. But yeah, in those cases, we just kind of a bit blind there, or we can log onto the box and have a look, or we can refer to our other backend. But if Honeycomb's down, there's basically there's a little background queue in the process which tries to send, and if that errors, then it just sort of drops them. I've had this same experience with like home rolled log backends when, sometimes the logging backend goes down and then you just lose logs from it, or worse. So one time, I think it was a Java-based stack, but no, I think it was the application was writing to syslog, and then syslog was forwarding, and then to a central, and ended up on a box somewhere, and then that box ran out of disk, and someone had, I don't know if they thought about it or this was just out of the box default, but it had been configured with back pressure. So what actually happened was the applications all crashed because one box filled up with logs. So of the two choices, I would always rather discard logs than take an outage when telemetry's down.
Yes, have to pick your priorities sometimes, don't you?
Yeah.
It's hard decisions, but I think those make sense. So absolutely. You sort of ended that talk on a bit of an interesting balancing question of what would you suggest around unified telemetry approach, and you kind of hedged a bit and said I think I'd suggest it, but maybe not. Often with these talks, we gain some more experience between when we deliver them and when we're actually here for the Q&A. So has anything changed around that? Would you be more kind of bullish in suggesting that unified telemetry approach?
So I don't think things have hugely changed. I think like the reasons I gave in the talk there, so it was just a bit weird. Everyone looked at me like I was crazy. Like, what are you doing? Like, and actually I've spoken to a few people that, oh yeah, we started doing this, and actually, yeah, it was great. Once you start doing it, it's like, yeah, this feels fine. But just having to convince people over and over and over again, especially if you're like a growing organization, when someone comes in and says, oh, how do we log? Oh, we don't do logging here. And they're like, what? Who are you? What are you doing? And I think so that effectively that's the biggest cost, is like getting people on board, getting people to believe that actually it's fine, don't worry about it, this works. And I think effectively there's a chicken egg problem there. Whereas if it becomes a more widespread practice, then the cost of convincing people goes down by quite a lot. So yeah, I guess maybe I'll submit this talk to a few other conferences and go from there.
Win people over one conference talk at a time, huh? That's fantastic. Yeah, I think this has been really great. I know I still have more questions about what ended up happening with the that shared library now that you've had this experiment. Did this roll back in and all that? But I think these are what we can take advantage of in the Hangout. So we've got a few more ways in which to ask you questions through the QCon Slack. If you're not already in it, please do join. And also for the next kind of 10 to 15 minutes, Glenn's going to be hanging out with us in Zoom. So go ahead and on the schedule page, there is a link to the Hangouts, and there's also, I think, maybe a link here in the chat. But yeah, let's go have a further chat about this experience with Event First Telemetry. Thank you so much again, Glenn. It was a fantastic talk.
Yeah, thank you very much.